Hello, this movie is a warm-up for Trig using similar triangles. So this movie is to show you where these trig functions come from. Let's look at the top of this page. Notice that the two smaller triangles are sitting on top of the larger triangle. We're going to call that large triangle, triangle A. So I'm going to highlight that in blue. So you can see that's the large triangle there. And then we've got the middle triangle, B, and B is going to be this red triangle sitting on top of A. And then you have a small triangle, triangle C, which I'm going to label green, sitting on top of the red one, sitting on top of the blue. So we've got a lot of terms here with these different triangles. And all these terms are going to be related to this angle down here, angle Z. So throughout this, I want you to pretend you're standing at angle Z. So if we're at angle Z, you can see that this side, and this side are all opposite to where we're standing. So if we're here at Z, triangle C has the opposite side, which is here, which we call SL, short leg. For triangle B, the red one, the opposite side to where we're standing is this one. And for triangle A, the opposite side to where we're standing is this one. So we call that the opposite side. In all three of these triangles, the hypotenuse is the longest side opposite the right angle. So this is the hypotenuse of C, this is the hypotenuse of B, and this is the hypotenuse of A. Then we have something called the adjacent side, and the adjacent side helps form the angle where we're standing, but it's not the hypotenuse. So if we're standing at Z, the hypotenuse has already taken this side. This side we call the adjacent because it is right next to where we're standing. And it also includes the long leg of triangle C, the long leg here of triangle B, and the long leg of triangle A. What I want you to do now that you kind of understand this diagram with the three triangles sitting on top of each other, the fact that we're going to be standing here at Z, we've got opposite sides and adjacent sides. The first thing I want you to do is to use a ruler to find each of the lengths. So I want you to measure in centimeters. And note, if you're standing at angle Z, then the O is the opposite side, which is also the short leg. So for triangle A, this is the opposite side length, which is also the short leg. A is the adjacent side, which is also known as the long leg. And H stands for the hypotenuse. Let me do triangle C with you, and then you can find the other measurements using a ruler. So let's do triangle C. Place a ruler down. We want to find the opposite for side, for angle Z. We're standing at Z. The opposite side is this length. Find that length in centimeters. And I will as well. You should get that is about 2.1. About. And then what we want to do, we want to find the adjacent side. The adjacent side length is going to be this one down here, which is the long leg. And you should get around 3.7. And then the hypotenuse, which is going to be the hypotenuse, the longest side of triangle C. And that should be around 4.3. So pause the movie, do those things, the opposite side, the adjacent side, and the hypotenuse side for triangles A and B. When you're finished, press play and we'll go through these. So your measurements might be a little different than mine, but this is what I got for triangle A. And here's what I got for triangle B. And what we can see about these three triangles is that all three of these are similar by angle. They all three have a right angle and they all three share angle Z. So we have three similar triangles and we found their measurements here. What we're going to do next is find the ratio of the opposite side. So this is how trig functions came about. They started to notice the relationship between the ratios of the sides of a right triangle. So that's what we're going to do here. Find the ratio of the opposite side over the hypotenuse for each of the 3 triangles. We're going to divide and round each to the 10th. So if we look at triangle A, I'm going to do in blue. Triangle A is right here. The opposite side is 4.9. The hypotenuse is 10. So I'm going to divide that. I get about 0.5. Now I'm going to do the same for triangle B. The opposite side, what I'm looking at is right here, and the hypotenuse. So the opposite side is 3.6. The hypotenuse is 7.2. And then I'm going to divide that and round to the 10th. I get 0.5. Triangle C, I had 2.1 and I have 4.3 for the hypotenuse. Divide and round and I get 0.5. So what we notice here is that whenever we take the opposite over the hypotenuse of any of the similar triangles, I always get the same ratio. And that's where trig functions came from, this idea that regardless of the size of the triangle, the ratio between the opposite and the hypotenuse side of this angle, whatever that angle may be, now that angle might be 32 degrees, 64 degrees, but of this given angle, it's going to be 0.5. We call that a sine. It's spelled S-I-N. Let me make this bolder. But it's not said sin. We call it a sine. And it's the sine function gives us the ratio. Now I'm going to put the sine function of z, of that angle, is the ratio of the opposite side over the hypotenuse. So the sine, which represents opposite over hypotenuse, of angle z, because that's where we've been standing the whole time, always gives us this ratio. And that's what the sine function is, opposite over hypotenuse. Pause the movie, fill out your content for numbers 2 and 3, and then press play when you are finished. Okay, for 2, 8.6 for triangle A. This gives me about 0.9, and this was 4.9, 8.6. This gave me about 0.6 for triangle A. For triangle B, I've got 6.3 and 7.2, which is about 0.9. I have 3.6 and 6.3, which is about 0.6. And then for triangle C, I had 3.7, 4.3, which is about 0.9. And I had 2.1, 3.7, which is about 0.6. So let's analyze this. We can see that when we're standing at this angle, right here at Z, if I take the adjacent side over the hypotenuse side, adjacent side is here, over the hypotenuse side here, I keep getting this ratio of 0.9. So they realize that any size triangle with this given angle, by angle-angle similarity, any triangle will have this ratio of adjacent over hypotenuse to be the same as 0.9. Now, it's only 0.9 for this given angle measure. If I extend Z to be bigger, the ratio changes. If Z becomes smaller in degrees, then the ratio changes. But this ratio of adjacent to hypotenuse is called cosine. So my cosine of my angle Z is always the adjacent side over the hypotenuse side. Down here, when we take our opposite over adjacent, if we're standing at Z, and we look at the opposite side divided by the adjacent, we get the same ratio regardless of the size triangle. That is true for any size triangle with this angle measure z. I will always get 0.6. Now it won't be 0.6 if z is larger or if z is smaller, but they will be the same ratio. And so because of that, we notice that we will always have the same ratio when we take opposite over adjacent. We call that the tangent. It looks like tan, but it means tangent of our angle z always equals the opposite over the adjacent. So what this worksheet is showing us is that our three trig functions, sine, cosine, and tangent, all stem from the fact that when we have similar triangles, all with the same acute angle measure and right angles, so angle-angle similarity, they will have sides with the same ratio. Opposite side to where we're standing, to what the angle is we're talking about, over the hypotenuse is always sine. Cosine is adjacent over hypotenuse, and tangent is always opposite over adjacent. These ratios hold true for any angle. So they started to make these books with all of the ratios for all the potentially different angles that you could have. For example, this angle could be about 30 degrees. And so the sine of 30 degrees, the cosine of 30 degrees, and the tangent of 30 degrees would give us these different ratios. And that's what we're going to learn in class, is how to use our calculators to find what these ratios are. They used to have books back in the day, and in fact in the 90s when, actually late 80s, they came out with graphing calculators that had all these measurements in, all these ratios in them. And so that is what we're using today, is the graphing calculators already have all these ratios programmed in, and we're going to use that to solve trig functions. So, sine, cosine, tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this little acronym here helps us to remember that. SOHCAHTOA. You'll see this in my classroom. It means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We will practice this skill more in class, but I wanted to intro you to show you how similar triangles relate to the trig functions we're learning. Thanks for watching.